So CNC machine connectivity is actually a relatively new capability for manufacturing software. Now in our case, in NC simulation and verification program, we have a digital twin of the CNC machine, and we'll actually make it mimic exactly what the machine does. Now that's great for verifying your programs, optimizing your cuts, making sure that you're staying with what the machine can do. That's the point of it. Now the connectivity that we're talking about helps you find out how the machine has been set up, the cutting tools that have been put in the machine, what all those set lengths are, and the purpose of checking all of these things, NC programs and all that data, is to see if it lines up with what you simulated. You want to make sure that those worlds are one-to-one. You don't want any differences between them, because every difference between them can cause you a problem when you go to cut the real part. So this connectivity capability is becoming increasingly more important to make sure that it was set up properly, no one's edited the NC program, and everything's ready to go. That makes the part run clean, and that's what we want in manufacturing. As I said, this is a relatively new capability, so we have lots of people out there testing it and finding out how this is going to work for them. And this has also given us an opportunity to keep on creating new content for them to try. So in addition to doing the checks that we talked about earlier, we can also archive the data as you run it, which means you can go back and investigate it later. So you can do the check up front, you can do the check afterwards, in case somebody points the finger at you and said, you did this or you did that, edited the program or whatever, you're able to go back and say, no, when I ran on the machine, this is what happened. This is the reality. And then what's left in the middle? What's left in the middle is while the machine is running. So I could be an NC programmer, which I was one at one point, and I want to know how my job is running on the shop. The only way I could do that was to go out there. We used to call it babysitting. Go babysit at the machine. Well, that's not very productive. I'm not making my NC programs that are due out of the shop later. So I can't do that. I can't waste time. So I have to let them run it. Then I would go and ask them, how did it run? Oh, fine. Wait a minute. I heard there was an edit. We might have edited something. Can you tell me so I can get it into the master source program? Because if we get an engineering change or something, I'm going to need to do that again. So back and forth, back and forth. Now I can connect to the machine with CNC machine connectivity. I can watch it run. I can see the overrides. I can see if they've changed the spindle RPM, the feed rates. It's all right there for me to watch. And I can just keep that running on my computer and do my other work, check in on it. It's a great convenience, no wasted time, and constant data right there at my fingertips. So check it before, check it after, watch it in between, as much as you need. This is a great way to make sure that the shop is doing what you, the NC programmer, asked them to do and documented in the pages that they use to set up. So CNC machine connectivity, who can use this? Well, think of it this way. Whoever has a CNC machine has all these same kinds of problems. And the more parts, especially new parts, that you run on your machines, the more likely you are to benefit from this. So as I said, it's a relatively new thing, but it's going to span across all industries, all people using CNC machines. There's a lot of shops out there, and every benefit is waiting for you to try. So let's talk a little bit about implementing this connectivity software. Where does it sit in the process? Let's back up a few steps and say, if I'm going to run one of these machines, I need to create the NC program for that machine. That's typically done through a CAD/CAM system. So a CAD/CAM system is going to be the programming system used to figure out what cutting tools to use, in what order, what are the sequences to manipulate the part to get the final product. So that's very important for a start, but it's just a start. So from there, we will post-process whatever I've done on my CAD/CAM system. That creates the NC code that's going to be driven on the machine. That's where the NC verification and simulation software comes in. So the advanced companies, the companies that don't want to make mistakes, don't waste money out on the machine, they use this software to see everything up front. They do a virtual run of this on the machine. They can tell exactly what it's going to work, what's not going to work, And when they need to make a change, they don't need to stop the machine and go run back to the CAD/CAM system in the programming department, make a new program, post it, run back down to the machine. They don't do any of that. Now they're sitting at their desk, they make a change, make a change real quick, re-verify, good, let's move on. How about we optimize? You can use that same software, the simulation, verification, and optimization software, if you choose the right software, to optimize your code, which means it'll be the right types of tools, cutting the right materials at the right feeds and speeds. Who doesn't want that? That's the fastest way to get quality parts. So when you're trying to set up this whole landscape, you want to do a little bit of homework and make sure everything plays well together. For example, the software that we have for NC simulation and verification will communicate to about 20 different brands of CAD/CAM software. It doesn't matter where that data comes from. What else do you need? Cutting tools. So again, connectivity viewed a little differently. You need to connect to all these different tooling companies and tooling repositories, Coral Plus Tool Library, TDM, for example. These are all things that bring data useful, in fact, valuable to the simulation, verification, and optimization environment. So connectivity is viewed a lot of different ways by our company. We'll connect to the CNC machine, but that's just one place. All these other data inputs give you high quality data to represent the real world. And that's what you're really trying to do here. You're trying to represent everything that you can, catch every problem that you can, be as optimal as you can, but safe. So is there anything left? Sure there is. If you think about this, once you're connected to the machine, machines monitor its own health. It knows about spindle power that was used. Many of them can report on vibration. There's new things coming out every day. And so you can learn from that machine. That's the true machine learning. Now, we're learning from the machine. Now, if we can take that information and start closing the loop back to CAD/CAM, we can take this whole NC manufacturing process and start iterating on it to learn when does the machine like what I'm doing. It's not vibrating, it seems to run well, the part's coming out good. You can loop in metrology, you can loop in probing, you can loop in all kinds of things. So we're not finished. There's quite a bit more to be done to create this whole environment where everything can start talking to one another, learning from it, and improving the processes. At the very least of which, you'll get longer run times on your cutting tools, even longer than optimizing, which you would get today. But you will also create better parts, and who knows, maybe it won't take programmers as long to make their programs, because some of those decisions will be made for them. This is going to be a very exciting way to work through manufacturing in the future. Here's a few tips for what you can think about preparing for this kind of an environment. Obviously, CAD/CAM programs by nature, they're rather weighty in terms of the amount of resources that they take. No surprise there, at least it shouldn't be, but the same is going to be true for your NC simulation and verification software. There's a lot of math going on there, especially when you get into optimizing in that. You want it to run fast. Nobody likes to wait for things these days. So you want to get systems and computers that have enough resources to do the work. A good tip to go by is if your CAD/CAM system requirements are met, then you're probably okay on the verification and optimization side as well. But you want to make sure you choose that, good graphics cards, all those things will make sure that your environment runs smoothly and you don't have hiccups along the way. So now when you have all of that in play, let's talk about best practices to make all of these things work together in a chain of use. CAD/CAM environment first, post-processing next, then simulation, verification, and optimization. The common thing between those is all the data that represents your digital setup. So most of that's going to come from your CAD/CAM system. That's why it's important that the data that goes in the front is high quality data, good models, clean models, tooling models, this is important, that are accurately assembled and put together, because that is what is going to go downstream to your verification. And you want that to be as real as possible. Now, if you think about that, once you get into the virtual world, you want to make sure that that gets documented. So there's tools in the verification software that do that for you. It reports the tools that were used, how they were constructed, the runtimes and all of that. It's only good if those same tool instructions go out to the shop and they build the tools the same way. So this top-down thinking is very important and my number one tip for you going forward in this environment to make it run seamlessly, work smoothly, and come out at the end like you expected. Between simulation, verification, optimization, and CNC machine connectivity, I'm sure I've mentioned a few things, maybe at least one, that's new to you. So when you go to work with this software, you don't have to do it by yourself. You can ask for help. So when you want to implement these things, in order to make it easier for you and less disruptive to your environment, you can ask for your providers to provide consultancy. They will come on site, they will help you install it, give you the tips on how to use it so you get a jump start and you're effective right away. You could try to learn it yourself, but why should you? Get the help that you need so you can get going quickly. Because in NC manufacturing, speed matters, quality matters. Keep to what you know, let the providers help you with what they know. They'll get you started. So if this sounds good to you, but you're busy, you don't have time, maybe you're short of NC programmers, any number of, let's call them excuses, why you can't get started today. Also keep in mind that there's help available for you as well. So again, reach out to your providers, find that they can help, and use those resources as much as you need to. Sometimes you can even get temporary help, people who will come in and do the work for you or train you as needed on site. But the worst thing in NC manufacturing that we hear from our customers is not doing anything. If you don't change what you're doing, rest assured, everybody around you is. This technology changes too fast to sit still. If you sit still, by definition, you're left behind because everybody else is moving forward.